All right, let's go ahead and talk about how we can come up with the formulas of ionic compounds. What's really important to note is to come up with the formula for ionic compound, you need to make sure that your charges are balanced. The overall compound has to be neutral, which means it has to have a zero charge. That means that if we have a 2 positive charge, such as calcium here, and a 1 negative charge, such as chlorine here, we would need 2 of those chlorines to balance that 2 positive. And so if we take a look here, this is going to end up being a 1 to 2 ratio. You have 1 of these and 2 of those. To give you another example, let's say we had aluminum, which is a 3 plus, and let's say we had fluorine, which is a 1 minus as well. We would end up needing a total of 3 fluorines. We would need 3 fluorines to balance that because this is a 3 positive and 1 negative. And so this would end up being AlF3. It would be a 1 to 3 ratio. Now, something to keep in mind is if there's nothing right here, it's assuming it's a 1. So it's a 1 to 3 ratio. So let's go ahead and do this. Now, I'm going to go ahead and name these first. And so we're going to do the naming first because they're pretty straightforward. And then we're going to come up with the formula. So for number 1, lithium bromide, this is going to be lithium. And instead of bromine, Br will be bromide. So again, we change the ending to "ide." Instead of bromine, it's bromide. This next one, again, we just named the first element here, which is beryllium. And then we named the second one, but we changed it to "ide." That's iodine, which changes to iodide. All right, aluminum. And instead of nitrogen, it's nitride. And then we have potassium sulfide. And again, so sulfur, it's sulfide. So that's how you name it. It's very straightforward. You just name the element, except for the second one you change to "ide." Well, now let's go ahead and come up with the formula. Now that we have the name, we need to come up with the formula. And so one thing we want to keep in mind is that we can look at the column that an element is in and determine the charge that it makes. So the first thing we want to do is determine the charge. Notice here's calcium, and calcium makes a 2 plus, and then here's oxygen, and oxygen makes a 2 minus. And the whole idea is that we need to balance the charges. So if calcium is a 2 plus, and I just like to write the charges above the element, and oxygen is a 2 minus, notice how one of each of them will be balanced. And so this will end up being a 1-to-1 ratio. And so because it's a 1-to-1 ratio, I'm going to write it over here, it's going to end up being CaO. And again, if we don't write anything, it assumes that there's a 1, so it's a 1-to-1 ratio. So it's just CaO, you just need one of each to balance each other. All right, let's go ahead and go to the next one here. So we have strontium fluoride. And so strontium, here we go, here's strontium. Again, that's a 2 plus. Now fluoride is a 1 minus. And so I like to, again, write the charges above. And in this situation, if you have a 2 plus and a 1 minus, the way you balance that is by having 2 1 minuses. And so we would need a total of 2 fluorines in this situation. And so we would have strontium, which is a 2 plus, but we wouldn't need 1 fluorine, we would need 2 fluorines to balance that. So that's a 1-to-2 ratio. All right, next one, aluminum sulfide. Okay, aluminum is right here, sulfur is right here. So aluminum is a 3 plus, sulfur is a 2 minus. So let's go ahead and take a look at that. So aluminum is a 3 plus, 2 minus. And so in this situation, we have a 3 plus and a 2 minus. What you cannot do, is you cannot do this. You cannot do that. Because the idea is all we have are aluminums and sulfurs. And so aluminum is a 3 plus. And sulfur is a 2 minus. And all you can do is you can only have aluminums and sulfurs. And so notice how to balance this. You would need to have 2 of these, and you would end up needing to have a total of 3 of these. So notice when we have 2 aluminums and 3 sulfurs, it ends up being balanced. And so you kind of have to think about, how much of each would I need to balance that charge. So 2 aluminums, 3 sulfurs. And this would end up being Al2, because we have 2 aluminums, S3, and we'd have 3 sulfurs. All right, sodium is a 1 plus, nitrogen is a 3 minus. You can look at the periodic table to find that out. And to balance that, you would need to have a total of 3 sodiums and 1 nitrogen. You would need to have a total of 3 sodiums and 1 nitrogen. And that's it for the binary ionic compounds. Now again, binary ionic compounds means there's 2. Binary means 2. And that means there's only 2 elements involved. Now for polyatomic ions means that we have an ion that has 2 or more substances. And if you look at your polyatomic ion sheet, it's like on the very first page in your booklet, you'll see there's a list of polyatomic ions. So go ahead and find that. And it's really easy. So whenever you have 3 elements like this, usually the last 2 elements are going to be the polyatomic ion. And so if you look in your polyatomic ion sheet, you'll see SO4 is sulfate. And so this is going to be calcium. You just named the first one. And it's going to be sulfate. This is magnesium. And then PO4 is phosphate. So you kind of have to look at where the polyatomic ion is. So that's phosphate, magnesium phosphate. Then we have strontium. And then BrO4 is perbromate, sorry. And there we go. So that's the naming of it. So you just name the first part, and then you name whatever the polyatomic ion is. Now for this next part here, it's the same thing. You want to look at the charges they make. Now, here's a quick tip. Notice how these all end in "ide." If it ends in "ide," it is a binary ionic compound. That means you find this on the periodic table. If it ends in "ate" or "ite" with a T, it's going to probably be a polyatomic ion. So again, you want to look at this last part. So it's 8, so it's a polyatomic ion, or ite with a T. If it ends in ide with a D, it's a binary compound. All right, so sodium is a 1 plus. Now if you look at your polyatomic ion sheet, you will see that that chlorate is right here, all right, and it's ClO3 1 negative. Now notice how there's 3 oxygens, very important here. Notice how there's 3 oxygens, and notice how it just says negative. If it just says negative, that means it's a 1 negative. If you only see negative, that means it's a 1 negative. So this is a 1 negative. Now notice it's a 1-to-1 ratio. So in this situation, we would end up with Na. Now chlorate is ClO3. You have to have the 3 there because it is ClO3. And so you would write the ClO3, but only have 1 of them. And I'll show you what you'll do if you have 2 of them. So it's NaClO3. Now aluminum is a 3 plus. You can look on the periodic table for that. And then nitrate, if you look at your polyatomic ion sheet, nitrate is right there. It's NO3. And again, if it just has a negative, that means it's a 1 negative. So the small 3 on the bottom tells you the number of oxygens. The number on the top tells you the charge. And so this is a good example. Carbonate is CO3, and then you have the 2 negative, which means it has a 2 negative charge. But anyways, nitrate is a 1 negative. And so what that means is to balance the charge, we would need a total of 3 nitrates. And to represent that, this is how you do that. So we have aluminum. Now nitrate is NO3. That is nitrate, so you have to write NO3. Except we don't have 1 nitrate. We have 3 of them. And so to show that, you have to put the polyatomic ion in parentheses, and you put a 3 on the outside, showing that we have 3 of those nitrates. To give you an example, notice here, how many phosphates do we have here? Again, phosphate is PO4. We have 2 phosphates. So again, you got to put it in parentheses, and then you put a 3 there. Sodium, 1 plus. Carbonate, if we look at our polyatomic ion sheet, again, there it is right there. So it's CO3 2 negative. And we end up with a 2 to 1 ratio. So sodium is going to be Na2. We need 2 sodiums because 1 positives will balance the 2 negative. And then carbonate is CO3. So we have to write the we have to write the 3 there because carbonate is CO3. All right, let's go ahead and go to the next one here. Okay, so these are hydrates, and this is all you do is you name this part normal. All right, just name that part normal, but then you add octahydrate, tetrahydrate, trihydrate. So again, you just name that first part normal. So strontium chloride. And then octa, which is 8, hydrate. All right. And there we go. So sodium oxide tetrahydrate and then calcium carbonate trihydrate. And it's that straightforward. Let's go ahead and do this next part. So this next part is just like the other one where all you do is you write the formula for this. So you write the formula for this just like what we're doing in the previous practice problems, and then you just add the hexahydrate, which is 6 water, heptahydrate, which is 7 water, nonahydrate, which is 9 water. Now, what I want to show you here is notice how this here also these 3 compounds look very similar. The only difference is this is sulfide, sulfite, sulfate. And what I'm really trying to show you here is that if it is IDE, it's a binary compound. If it's ITE, it's a polyatomic ion, or ATE, polyatomic ion. So if it ends in an IDE with a D, it's going to be binary. If it ends with an 8 or an ite with a T, it's a polyatomic ion. And when you write the formulas, you end up with this. So again, calcium is a 2 plus, sulfide is a 2 minus, so it's a 1-to-1 ratio, and then we do a little raised dot, and we do 6 waters because it's hexahydrate. Again, sulfite is SO3 2 negative, calcium's a 2 positive, that's a 1-to-1 ratio. And then this here, sulfate is SO4 2 negative, and calcium's a 2 positive, 1-to-1 ratio, and then we do the 9 waters because it's nonahydrate. All right, so what we're going to do now is I'm going to actually do these first before I do the naming, all right? This has to do with transition metals, and transition metals have multiple charges. For example, chromium can be a 2 plus or a 3 plus, and so let's go ahead and do this. So if you look at the periodic table, you see the charges here, but what about these? So chromium, what is the charge of chromium? Well, you cannot tell a charge just by looking at the periodic table. You have to be told what the charge is. And so what is telling us the charge here? So what is telling us the charge? This is telling us the charge. What that is telling us that chromium is a 2 plus charge. That's what this means. Now chlorate, if we look here, it's an 8. So it's a polyatomic ion. Here is chlorate. It is a 1 minus charge. And so what we will end up with, a 1 to 2 ratio. So it's going to be Cr And then chlorate is ClO3. So you have to put the 3 there. But we don't have 1 chlorate, we have 2 chlorates. And so we put a 2 there, we put it in parentheses and put a 2 there to represent that there's 2 ClO3s. All right, iron. Okay, so here's iron. Oh no, we don't know what the charge is. Well, that's because it has multiple charges, and it tells us right there. So iron is a 3+. Now let's look at fluoride. Fluoride is a 1-. Okay, so we do know what that one is. And so we go 1-. Oh, what am I? I'm sorry. It's not a 3+, it's a 2+. Probably really confused there. So it's a 2+. So that means that iron, there'll be 1 iron, and to balance that 1 iron, we would need 2 fluorines. All right, so this one's got a hydrate as well, so lead 2. So if you take a look, lead is right here, and you would think that maybe it's a 4+, which it could make a 4+, but it also makes a 2+. So lead is a variable charge as well. So it tells us right there that it's making a 2+. So this is a 2+. Because it's ending in an "ide," that means that it's a monoatomic ion, which means it's sulfide. It's 2-. So again, if it ends in "ide," it's just one of the ones on the periodic table. And so this is a 1-to-1 ratio. And I'll write it up here. So it's going to be lead 2 sulfide. And then we need to put the little raised dot there, and it's tetrahydrate, which is 4 waters. Okay, let's go ahead and go backwards now. What you need to recognize is copper is a transition metal, so you do need to recognize that, and you need to recognize that iron's a transition metal as well. So what that means is you need to say what the charges are, and so this is how you think about it. So this is chlorine is a 1-, and so what must this be? What must the copper be to balance that 1-? Well, the copper here must be a 1+, and so what we will end up with is copper. But we can't just say copper, we have to say copper 1. So we do a Roman numeral in parentheses there. Chloride. And you don't have to do the parentheses, but you will see it with that. Chloride. So it's copper 1 chloride. Okay, well, again, if this is a 1-, what must the copper be to balance that? Well, in this situation, it's not just a 1+, it's a 2+, because there's not 1 chlorine, there's 2 chlorine, so that means we have 2 negative charges. So this is going to end up being copper 2 chloride. So notice the difference there. One has a 1+ and one has a 2+. Now, something I really want to highlight here is this here does not tell us how many coppers or how many chlorines there are. What it does is it tells us the charge. Very important. All right, so this one here, oxygen is a 2-. However, how many 2 negatives do we have? We have a total of 3. There's 2 irons here. And so the question is, what must the charge of iron be to balance this? So again, we have 3 oxygens. Each oxygen is a 2-. We have 2 irons. So what must each iron be to balance that? Well, each iron must be a 3+ to balance that. And so what that means is this is going to end up being iron 3 oxide. And that's it. So go ahead and do the independent practice problems. It's very important that you do this, these practice problems. It might be a little tedious at first, but you need to get to the point where you're very comfortable with coming up with these formulas. Very important. And if you have any questions, feel free to email me. Have a great day.